Bismillahirrahmanirrahim. Assalamu alaikum. It's our 24th lecture of Advanced Electromagnetic Field and Waves, and in this lecture we are going to solve problem number 1.9.16 from book Jackson. Okay, so the problem is a thin layer of antenna of length, okay, which is sinusoidal current makes a full wavelength of oscillation. There is an antenna of length d, which is excited in like a way like it makes sinusoidal current, which makes full wavelength of the oscillation. So first part, what you have to do, you have to calculate the exactly power that radiate per unit solid angle, okay, and the angular distribution of the radiation. So you have to find first the exactly power radiated per unit solid angle, means dp by the omega you have to find. How you can find? So for this you must have to know about the source term, because you know that in radiation's formula this is, whereas a, which is the vector potential, equals to mu naught by 4 pi e power iota k r divided by r, volume integral j x prime e power minus iota k n dot x, this, where this g of x is basically the source term. So in that scenario, when there is a wire and your current is like a sinusoidal current flow in the opposite direction in top and bottom, because this is sinusoidal, this is one direction, this is other direction, so it is opposite current flow in the opposite direction in the top and bottom of the antenna. So in that case your source term can be written as this. You have to know that z prime I naught sine of kz, because your wave is propagating in the z direction, that's why your source term in the z direction. So z bar I naught sine of kz delta x delta y, and this is your just denotation of d by 2 and z bar. So only the important is this, you have to know z prime I naught sine of kz. You have to use this expression in your vector potential formula, because you know that your wave propagation k is equals to 2 pi by lambda, but lambda is the wavelength, as in question it is mentioned that the total wavelength is d, so that's why it becomes 2 pi by d. Okay, now what you have to do is just to have to use the vector potential formula, which is this, as I mentioned you before, but in this formula this n cap dot x prime becomes equals to z prime cos of theta. Okay, because your wave is propagating in the z direction, so you can see z prime cos of theta it becomes. Now you have to use the Euler formula here, because you know that e power minus iota and this whole term is theta, k z prime cos of theta. Let's suppose this is theta, so formula is e power minus iota theta, and you know that e power minus iota theta can be open as sine of theta, sorry, cos of theta minus iota sine of theta. This is the Euler formula you have to open. First of all, just put your value of jz, which I mentioned you the value of jz, as I mentioned you that z prime, which is z prime here, and I naught is constant, that's why it becomes outside, so it becomes mu naught I naught divided by 4 pi e power iota kr by r, as it is. Integrate, because as I mentioned you that full is the length, and the half wave is distance is d by 2, and the half wave distance is d by 2. So the lower limit is minus d by 2, upper limit is becomes d by 2, and inside is the sign kz, inside the sign kz, because here is prime, so that's why prime, and e power minus iota kz cos of theta, as it is, and this z prime is here. And now you have to integrate our z prime, because this is all z factors. Now what you have to do, open the Euler formula, as I mentioned you before. Sine is on their same side, but you only have to open this. So once it open, it becomes cos of kz cos of theta, cos of k, let just leave this, it becomes cos of kz cos of theta minus iota, leave this, sine of kz cos of theta. Why this term and this term? Because you know this term has to be multiplied with both factors when Euler formula is opened. So that's why this formula is this with this and this with also this. Actually formula is open this and iota minus iota and this term, and z and dz prime as it is. Now this term becomes 0. Why? Because your sine is basically an odd function and cos is the even function, so their product must be equal to 0. So this term is 0, minus iota is constant, it becomes outside, so it becomes minus iota mu naught I naught by 4 pi, and only you will left with this. Now what you have to do, you have to use the trigonometric identity. You know that sine theta, sine alpha sine beta must be equals to 1 by 2 cos of alpha minus beta minus cos of alpha plus beta. So 1 by 2 outside, cos of alpha plus beta, alpha is kz prime and beta is kz prime cos of theta, cos of, so you can see alpha minus beta minus cos of alpha plus beta, and this as it is. And now our next step is you have to, what you have to do, you have to take the kz prime common. So once you take kz prime common, so it becomes 1 minus cos of theta, and once you take kz prime common, it becomes 1 plus cos of theta. Now move our next step, which you in this one in you have to just integrate. So you know that integration of cos is basically sine of this divided by their angle integration. So sine of this divided by their angle integration is this, because you have to integrate our z, that's why this kz prime becomes only k, or 1 minus cos of theta, k 1 minus cos of theta, here k 1 plus cos of theta denominator, and the limits is minus d by 2 to d by 2. Okay, so in next step, you can see here what we have to do. We just have to make this k common, which is outside, so, and this z prime is also it's in this side, and dz prime is gone because you already integrate, so only left with z cap. So after you know that in denominator the LCM is 1 minus cos square theta, and 1 plus cos square theta becomes 1 minus 1 minus cos theta, 1 plus cos theta. When it multiply, it becomes 1 minus cos square theta, and you know that 1 minus cos square theta is basically equals to sine square theta, that's why sine square theta. And when you solve the numerator term and putting the limits, you will get sine of pi cos of theta, sine of pi cos of theta, and there is a factor of 4 also. Okay, and this 4 cancels with, and this 4 2s are 8 and 2 2s are 4, so it becomes 4 pi square, and upside is same. And next thing is you have to put the value of k. As I mentioned you, the value of k is 2 pi by d, so the value of k 2 pi over d, and so that's why it becomes, so after cancellation 4, it becomes 4. So this is your final expression of vector potential in that scenario of wire, okay, which makes sinusoidal current. So but we need not the vector potential, we basically need the power radiated per solid angle. So for that we also need dipole. Okay, we also need dipole, we also need the electric dipole. And you know that electric dipole, we already derived this expression where your vector potential in term of dipole can be written as minus mu naught by 4 pi e power iota kr by r minus iota omega p, which is the dipole moment. Okay, so this is the formula which we already derived in our previous lecture, you can watch from there. And because we have to need to find first dipole. Why we are finding dipole? Because in our power radiated per solid angle we need dipole. That's why we have to use this dipole formula. And why we find vector potential? Because in the formula of dipole we need vector potential. Understood? Okay. So here is basically this. Um, uh, we have to find this, you have to multiply other side, this divide to the other side, you will get with this. And all the terms constant is here, and you have to put the value of this vector potential, which is this. So minus cancels with this, minus minus plus, 4 pi r cancels with 4, 1 pi and r, and this mu naught cancels with mu naught, e power iota r cancels this, you will only left with this, and there is 1 pi there, and there is omega which is left, and I naught d upside. So I naught d divided by omega pi sine of pi cos of theta divided by sine square theta in the direction of z. So this is your electric dipole moment. Okay, now what you have to do, you have to put this value in your main term, which is your, what you have to find is the power radiated per solid angle. And the formula of power radiated per solid angle is c square z naught divided by 32 pi square k power 4 p square sine of square theta. Okay, so here you have to square the dipole moment, which you already find here. You just have to take the square of this and put in this formula. So c square z naught by 32 pi square as it is, and k4 as it is, and p square is I naught square d square divided by pi square omega square. We are taking the square of our magnetic moment, and sine square theta is as it is, and in the magnetic moment term sine it is sine pi of cos theta, so now it becomes sine square pi cos of theta due to this square, and denominator is sine square theta, and when you square it becomes sine of 4 theta. This square cancels with this, only left with square, and this pi, you have to put the value of d. You know that k is equals to 2 pi by d, and so d equals to 2 pi by k. So you have to put the value of d, which is 2 pi by k, and their square. So that's why it becomes 4 pi square by k square. So pi square cancels with this, and k square cancels with this, omega square cancels with this, some terms cancel, and you will left with your final power radiated per solid angle, which is equals to z naught I naught square divided by 8 pi square sine square pi cos of theta divided by sine square theta. Understood? So this is basically your final power radiated per solid angle. The next part, it says that what you have to do, you have to find the total power radiated. We already find, but find their numerical value. Find their numerical value. This is your okay formula type. You have to find the numerical value of the radiation, value of radiation resistance. Okay, in terms of resistance, you have to find. So what you have to do, you just have to integrate this, our solid angle, integrate our solid angle. So you have to take two integral, one from 0 to 2 pi and one from 0 to pi, and because you have to integrate our solid angle, so that's why there is a factor of sine theta inside and d phi. Okay, so z naught I naught by 8 pi square as it is this, and this is as it is, and due to solid angle it d theta d phi. And after conversion of this to azimuthal integration, your what is left with, you will left with only one integration from 0 to pi only, and what remains is d phi gone, and this factor 8 becomes 4, and 8 pi square becomes 4 pi. Okay, so you have to integrate from 0 to pi, and this is as it is, and this, and now you have to let this cos of theta at as x. So dx becomes minus sine of theta d theta. So here you can see sine of theta d theta. So sine of theta d theta equals to minus dx. So dx minus comes outside, and pi, this is x, so this is x, and sine square theta, basically you know that 1 minus cos square theta, and cos is basically x, so it becomes 1 minus x square. Understood? Once you take the integration of this by putting the limits 1 to minus 1, your limits also changes, because you have let x cos of theta, and when you put 0 cos 0, you know 1, that's why lower limit is 1. And up limit, how you can find, by putting the value of pi, in which what you let cos of pi is basically minus 1, means cos of 180 equals to minus 1, that's why your up limit is minus 1. So after taking integration and applying the limit from 1 to minus 1, and you will get minus 1.5 answer. So minus 1.5 multiplied by this minus, it becomes plus 1.5, and this as it is. Now he says that you have to find the power in term of resistance. You know there is a formula of power, P is equals to, you know the formula of power, which is P is equals to I square R. So it becomes P is equals to 1 by 2 I square R. This is the formula. If you want to find resistance, so 2p divided by I naught square, it becomes 2p value is this, z naught I naught square 1.5 divided by 4 pi, and I naught square is this, I naught square cancels with I naught square. Okay, so once it cancel, and 2 ones are 2, 2 twos are 4, and so it becomes z naught multiplied by 1.5 divided by 2 pi. So after multiplying and divide by 2 pi by 1.5 divided by 2 pi, you will get your answer, which is 0.25. And z naught is as it is. So this is basically the total power radiated, and this is the numerical expression of the total power radiated of the radiation resistance. This is R, is basically the radiation resistance. So that's all for our today's lecture. Okay, in which we already drive uh, formula this problem 9.16 of book Jackson. Okay, so this is our problem. So if you have any query, you can just leave a comment below. I will definitely answers your questions. So in upcoming video we will discuss more interesting topics of advanced electromagnetic field and waves course. Till then, take care and Allah Hafiz.